Hello and welcome to this lesson about patterns, equations, and graphs. Today's learning targets include, first, to tell whether an ordered pair is a solution to an equation. Remember, an ordered pair is x comma y. We're going to use a table, equation, and graph to represent a relationship. And finally, we're going to use an equation or a graph or maybe even a table to make predictions about a particular relationship. So let's get started. The first thing we want to do is determine if an ordered pair is a solution of equations. Okay? A solution of an equation with two variables, x and y, is any ordered pair that makes the equation true. So the way we determine if a point, an ordered pair, is a solution to an equation is we plug in the x and the y values and see if it makes the equation true. So for this example, we have y equals 4x, and we're testing the point 3, 10. And notice that 3 is an x value and 10 is a y value. So we're going to rewrite this equation, y equals 4x, from left to right, and we're going to replace the variables with the numbers that equal them. So y is 10 equals 4 times x, which I see here is 3. So I've just rewritten the equation, and in place of the variables, I've put the numbers. So 10 equals 12. That is not true, so no. The point 310 is not a solution, okay? It does not make the equation true. So I'd like you to try these 4 examples doing the same thing. Pause the video, try these 4 examples, and then hit play to see if you've gotten them correct, okay? All right, now that we're checking, let's see what we've got here. Yes, this is a solution. Right? Remember x and y. X and y. We've got y equals 4x, so negative 20 equals 4 times negative 5. That is in fact true, so yes, this one is a solution. We have x and y, we have y equals 4x. Negative 5 equals 4 times x. Negative 5 equals negative 80 is not true, so this is a no. And finally, x and y, 6 equals 4 times 1.5. That's true, so that's a yes. All right? Hope you did well on those 4. Okay? And now we're going to look at an example of using a table, an equation, and a graph to describe a pattern. So let's read this problem together. It says ages. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. Okay? So I'm going to make a note here. Kim was born 2 years before Carrie. Good to know. How can you represent the relationship between Carrie's age and Kim's age in different ways? Well, let's think about what this means. If Kim was born 2 years before Carrie, that means Kim is 2 years older, okay? Her age is 2 years more than Carrie's. So let's start by making a table, all right? If Kim is 2 years older than Carrie, right? If Carrie's 1, when Carrie was 1, Kim must have been 2 years older. She must have been 3. When Carrie was 2, Kim was 2 years older than her. She was 4. When Carrie was 3, Kim was 2 years older than her. She was 5. And you may see where this is headed. Carrie was 4. That means her sister Kim was 2 years older. She was 6. And you may be able to infer that this is going to keep going in this way. All right? Such that when Carrie was 10, Kim was 2 years older, she's 12. All right? So we've filled in the table. All right? Now let's talk about the equation. All right? So I know when I'm writing a table, in general, I'm using x first on the top and y on the bottom here. Okay, so these two are the x and y values. And we're looking at step 2, write an equation. Let x equal Carrie's age, let y equal Kim's age. From the table, you can see that y is always 2 greater than x. I do see that in this table, that all of Kim's ages are 2 more than Carrie's age. So if I'm looking at what I just underlined here in blue, let's think about how we translate that. Y is, okay, is always, that's an equal sign, 2 greater than x. Greater than, that to me sounds like more than, which is plus. So I could say 2 plus x or x plus 2. Okay? And yes, x was Carrie's age, y is Kim's age. Here is our equation. All right? And now the last step of this is to make a graph. All right, now I've got the table already filled in. I'm going to label some things on this graph. I'm going to label the axes. I'll move this over so I have some space here. X is Carrie's age. And y is Kim's age. Okay, so that's the y-axis. This is the x-axis. Remember, this is x and y. And I'm going to put these points on. Notice that I've used a first quadrant graph instead of one of these, because there will be no negative values for either of the ages here. So I'm going to plot these. I'll say 1, 2, 3, 4, 5, 6, 7. I'll do something over here. 1, 2. Please use the grid lines on your graph paper so that your graphs are neat and are scaled accurately. Okay? And be careful here that if you do like I did and you did 2 spaces from 0 to 1, make sure that you're using 2 spaces between 1 and 2, and 2 and 3, and so on. Okay? So now let's put the points on the graph. 1, 3, 2, 4, 3, 5, 4, 6, let's see, very darkly, 5, 7, and that's all I can really fit on my graph for right now. So when I look at this, I know ages are continuous. Like I go from like 29 years old to 29 and a half to 30. I could say I'm 30 and a quarter. You know, when you're a little kid, you really talk about like I'm 9 3/4. You can talk about ages in between these whole numbers, so that is one reason why it makes sense to connect the dots on this graph, because you can continuously age between years, okay? It makes sense to have parts of years when you're talking about your age. And the other thing I want to point out is that we are going to draw an arrow on the end to indicate that this information continues on. It doesn't just stop where my graph stops. It continues on. So there's a graph. So we did a table, an equation, and a graph. All right. I'm going to go on to the next problem here, which is inductive reasoning, which is a process of reaching a conclusion based on an observed pattern. So you can use inductive reasoning to predict values. So we're going to make predictions based on our tables and our equations. So problem 3 says the table, this table here, shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend to the pattern. What is the total number of tiles in a figure with 8 blue tiles? Okay, so what we're trying to answer here is this. What is the total number of tiles in a figure with 8 blue tiles? Okay? Well, first thing, my first method to answer this is to extend the table. So I'm going to try that, okay? I'm going to look and see if I can figure this out. I've got 1 blue tile here has 9 total tiles. I see that in the table, okay? And every time, I have 2 blue tiles now, every time it seems to be adding 9 more total tiles, like another one of these blocks, okay, of 9. So here's 3 blue tiles, and now it's adding from the 2 that we had before another 9 tiles. So I see that 1 has 9, 2 blue tiles gives me 18, 3 blue tiles gives me 27. It looks like every time it's adding on 9. So I can figure when I get to 6, it's going to add another 9 tiles. 7 is going to add another 9 tiles. So when I get to 8 blue tiles, I'm going to expect that there will be 72 total tiles. That's my prediction using this table, okay, and the pattern. Okay, so let's look at how we could write an equation. All right? Let's write an equation. So let's take a look at what we have here. I'm going to erase some of this, okay? I'm going to try to figure out how I can describe the pattern, the relationship between x and y. If I know 1 takes me to 9, and 2 takes me to 18, and 3 takes me to 27, if I'm really clever with my multiplication facts, I'm seeing that y is 9 times x. Like whatever the x value is, I multiply it by 9, and I get to the y value, okay? So what I'm looking at here is an equation that looks like y equals 9x, okay? Where x is the number of blue tiles, and y is the total number of tiles. So back to our question here in yellow, what is the total number of tiles in a figure with 8 blue tiles? So what we're looking for is the total number of tiles. We're looking for y when we have 8 blue tiles. That's when x equals 8. So I'm going to plug in x equals 8 here and figure out what y is. 9 times 8. Okay? So I'm going to get y equals 72 total tiles, which is the same thing I had here. So this was 2 different ways to make a prediction based on a pattern that we were given. We could extend the table, or we could write an equation and use it. So thank you for watching this video, and we'll discuss this more in class.